Okay, hello everybody. I am Somnath Hazra, a second year PhD student at the Department of Computer Science and Engineering at IIT Kharagpur. So welcome back for the week 2 of the NPTEL live session on CS100 operating system fundamentals. So this week in this 1 hour duration we will be discussing some of the questions about operating system structures. So this is the second week of the course. Okay, so people are joining, no problem. Okay, so let's move to the first question. So this is the first question. So the question is that a task is accomplished by executing a file containing the required commands in which type of interface? Command line interface, graphical user interface, batch interface, or none of the above? So is there anybody who would like to contribute? I do not see any answers yet. Answer A. So you need to execute a file that contains the required commands. Anybody else? Okay. Okay, this time I see huge number of people joining. Yeah. Nice. Okay, so I am audible clearly, right? Okay.
Yeah.
Okay, anybody else would like to contribute to the answer? I only got one answer. So you know what command line interface, graphical user interface, batch interface, these are, right? So in command line interface you type a single command, like you want to move a file from one place to another, so you write move, then the source of the source file, and then the destination where you want to move the file. So in Unix you write mv for move, that is the move command. So in graphical user interface, you of course we know that in modern operating systems like Windows or Linux, Ubuntu, so what you do is that you have the option of a mouse which you use to, suppose, move a file or copy a file. You use the graphical user interface, graphical menu driven, the menus that are displayed on the screen to perform a certain task. Batch interface, we work with files. Okay, I got another answer. Okay, let's go to the answer now, right? So yes, batch interface is the answer, where a lot of commands that needs to be executed, they are written in a file, and that complete file is executed all at once. Okay, so batch interface is the answer. So let's move to the next question. So the command interpreter used by Unix operating system itself contains the code to execute a certain command, identifies the required file to be loaded into the memory, is small, and allows easy addition of newer commands, or none of the above. So in by command interpreter I mean that when you're working with command line interfaces, you type a certain command. So how is that command interpreted? Is with the help of a command interpreter. So every operating system has its own separate implementation of command interpreter. So this question relates to the Unix operating system, the command interpreter of the Unix operating system. So which of the among the four answers, there may be more than one possibilities also. So which among the four are you do you think are correct, is or are correct? Would anybody like to contribute? Okay, please keep your microphones silent, because it becomes very difficult otherwise, because there are huge number of attendees. I see it's already 99. So anything, if you want to contribute, you can just send in your answers through the chat box. So this time there may be more call drops and joins. So anyway, let's get to the question. So I'm audible, right? Yeah, okay. So let's get to the question. I don't have any answers yet. So anybody would like to contribute? Anyway, okay, somebody says A, okay. There may be more than one option correct also. So yeah. It's okay if, yeah. So let's get to the answer. So the command interpreter that is used by the operating system, the Unix operating system, that is, that identifies the required file to be loaded into the memory and is small and allows easy addition of newer commands. For example, if you type the command to copy a file, so you in Unix you write cp, then the source, and then the destination where you want to copy the file, source of the file, and then the destination where you want to copy the file. So what happens is that, so the command interpreter then searches for the appropriate file that contains that contains the actual commands that needs to be executed by the operating system in order to copy a file. So when we are typing cp for copying a file, for example, so there is actually a file cp that contains the actual code that needs to be executed in order to copy the file from a certain source location to a certain destination location. So not only for copying a file, for other commands also. So for any command that needs to be executed, there is a corresponding file that is located in a particular part of the memory, which the operating system knows where to look for. So when how this helps is that, so it keeps the command interpreter small, since for each and every command all the details that need to be executed are not itself written in the command interpreter. The command interpreter stays small, plus it is very modular. Newer commands can be added with ease. So it just needs a new file to be executed, and then the command interpreter will automatically search for that file when the appropriate command is asked for. So this proves to be very easy system. So yeah, and of course it itself does not contain the code to execute for the certain command. For example, I told you in case of copy. So the code to execute for when the command for copy needs to be run, that is not itself present in the command interpreter. There is a separate file for that, and the command interpreter simply searches for that file and then executes whatever is written inside that file, right? So these two are the answers. Let's move on to the next question. So which of the following OS service helps to manage permissions related to a file? Can anybody contribute? Is it IO operation? Is it file system manipulation? Is it communication? Is it program execution? These are all operating system services, right? So which among the following do you think helps to manage the permissions of a file? Okay, it says B. Anyone else would like to contribute? Anybody else? So this time we have many more attendees, but the answers are a bit low, so I don't know what is the problem. Anyway, I'll try to keep it engaging. It may be because of the theory questions, too many theory questions. So yeah, I'll try to keep more and more numericals. So anyone else who would like to contribute? It doesn't matter if you are wrong or right, you can give it a try. Okay, A, C, okay. So IO operation is an OS service which helps in input-output operations. For example, if you want to print something onto the screen, then that is managed by IO operation. Or if you want to, whatever you type on the keyboard, that is read by the operating system first. The keystrokes are read by the operating system, and then it sends it to the appropriate program. Suppose you want to type in something to the into the text editor. So the text editor program then gets the signals, proper signals from the OS service, from the operating system, which says that this key has been pressed. So this all happens, of course, very fast. Otherwise, we will keep typing and then the letters will keep appearing very slowly. So this is what the IO operation means. Communication can mean many different things. Communication may mean inter-process communication, intra-system communication, or inter-system communication over the network also. So these are also managed by operating system. Program execution we'll study later, that how this is managed. This is a very important part of the operating system, that how a program is executed, managing this. So as you can understand, of course, everything else, everything is a program in our computer. Whatever you write is a program. Whatever is being executed is a program. So managing that is, of course, one of the fundamental jobs of operating system. So yes, but managing the permissions related to a file, that is by permissions, yes, of course, by permissions we mean whether something can be written to a file, whether something can be read from the file, or whether something can be appended to a file. So these are the three primary permissions related to a file, that is read, write and append. So yes, these are of course related to the file system manipulation service from the operating system. So this is the answer, that is file system manipulation. This is the OS service that relates to the permissions of a file. Okay, so B is the answer. Okay, anyway, so let's move to the next question. So in the previous question we saw 4 types of operating system services. They were all operating system services anyway. So can you from the following services, can you identify which are operating system services? That is, does the operating system provide a user interface? Does it provide error detection? Is it an allocator of resources? Or does it provide for protection and security? There can be multiple correct answers. Okay. Okay. So user interface is whatever we are seeing on the computer, right? Even now whatever seeing on your desktop also. So that is the user interface. Okay. So error detection means a code may run into an error, or a program may ask for a printer when it is not even connected. So these are all the error detections. Or for example, if somebody is familiar with C codes, a very common error is segmentation fault. So that is an error detection. If you have worked with Unix, you may see. Protection and security, yes, some of the sectors of the operating system, like the kernel, they cannot be read or they cannot be written into, or in case of multi-user operating system, a single one user cannot look into the execution of or the files and processes of another user directly without any security measures. So these are all the so these are related to protection and security. Resource allocation, of course, if a code needs execution allocation of a printer, or another code needs a scanner, so program, sorry, if a code needs to print something, or if a code needs a scanner, so those resources will be allocated by the operating system itself. So because that is the operating system is the central part, is the central software that holds the key to all these resources. So if any resource is needed, so that will be allocated by the operating system only. Okay, so yes, all of these are answers actually. All of these are operating system services. Okay, yeah, some of you did identify it correctly. Okay, so let's move on to the next question then. So the dash serves as the link to the system calls provided by operating system. Is it application programming interface? Is it system call interface? Is it user application? Or is it all of the above? So will anybody like to contribute? Which among the four do you think serves as the link to system calls provided by operating system? So the system calls, as you know, are certain calls that are provided by the operating system. For example, asking some resources, for asking some resources, or access to an external hardware or something like that. So yeah, these are the system calls. Okay, I got some answers. Okay, yeah, so system call interface is the answer for this question. So yeah, this whenever we ask for there are certain routines that certain system calls that are provided by the operating system, but we do not generally directly use those system calls. So for example, printf is a very good example. So when we call printf, the system call interface intercepts the printf operation, and it identifies the actual write. It is actually a write system call that needs to be called. So write to screen is actually this actual system call that is executed by the operating system. So yeah, that is intercepted by the system call interface, and then the appropriate execution carries on. Application programming interface is the certain functions that are provided to us that we actually use, we as users or users of an operating system, we actually use to communicate, that we use when we need a certain system call, but those are not actually system calls. They are intercepted by the system call interface, and then the appropriate system calls are made. Okay, so yeah, this is the answer. Let's move on to the next question. So I've already I think answered this question. So yeah, printf is a system invokes a system call. So yeah, this code has. So let's move on to the next question anyway. So can anybody answer that this question related to Unix operating system? That Unix operating system consists of system programs, consists of a kernel that contains everything below the system call interface and above the hardware, that provides general operating system functionalities, or all of the above. So which is the best possible answer according to you? Can anybody say? So there are two main types of programs, as we had discussed in the previous session, that is application programs and system programs. So system programs are majorly part of the operating system. Kernel also we had gone over very briefly in the previous session. And general operating system functionalities, we saw some operating system functionalities in this session in two questions. Okay, I got some answers. Anybody else? So Arnav is regularly contributing. Thank you. I see Shweta's also answer. Anyone else? Anyway, let's go to the answer. So yeah, all of the above are correct. So Unix operating system consists of system programs, of course. The kernel contains everything that is below the system call interface. That is, system call interface is actually responsible for the proper system calls, and that is present above the hardware. It is kernel is the link between the system call interface and the hardware. And yeah, Unix operating system, of course, it needs to provide all the general operating system functionalities, otherwise it may not qualify as being called as an operating system. So it needs to provide the general operating system functionalities. Any operating system needs to provide the general operating system functionalities. So yes, all of the above. Okay, so all are correct. Let's move on to the next question. So a certain so this is a sort of numerical kind of question. So a certain operating system allows 2 seconds of CPU usage at a time per process in a cyclic manner. So for example, if there are two processes, so it will allow 2 seconds of CPU usage for P1, and then for process P1 for example, and then for P2, and then for P1 again, and then for P2. So this is what I mean when I say cyclic manner. So here we have three processes. Process P1 requires 7 seconds of CPU time altogether. Means by altogether I mean that in total it requires 7 seconds of CPU time. Process P2 requires 3 seconds of CPU time. Process P3 requires 2 seconds of CPU time. So which process completes its execution at the earliest? Which among the three processes P1, P2 or P3 do you think will complete its execution at the earliest? So these types of questions will be discussed in detail in the later part of the course, but this is just a very simple question. So yeah, you do not need to know much of the theory for this. And yes, of course, the execution starts with P1, starts with process P1, then move on to P2, then P3. Yeah, I missed out that. So yes, I got one answer. Anyone else? Okay, I got another answer. So how you solve these is using a chart that will be taught in detail later, because the actual questions of these types will not be so simple. So there are a lot of logic involved, as we will see later in the later part of the course as we progress. So anyway, this is quite a simple question compared to this. So anyway, so the answer is P3. So process P3 will complete at earliest. So that is because what will happen is process P1 will start with the execution, then it will get 2 seconds. So it needs 7 seconds. So after 2 seconds, the OS will swap, bring in process P2. It will swap out process P1. So still 5 seconds of process P1 is left to be executed. Then process P2 will be brought in. So it will execute for 2 seconds. So it still has 1 second of execution left. So then process P3 will be brought in by the operating system. P2 will be swapped out. So after 4 seconds, we still have P1 with 5 seconds of execution left. Process P2 with 1 second of execution left. So so after the 4th second, P3 comes in, it executes for 2 seconds, and that's it. It completes its execution. So yes, P3 executes first. Completes its execution earliest first. So yeah. So can anyone tell which process will complete its execution next after P3 completes, and at what seconds? What seconds of the clock? Considering that when process P1 starts its execution, the clock is at 0 seconds. So at what time instant which process will complete execution next? Yes, P1 will continue its execution for another 2 seconds next, but which process will complete its execution next? Is it P1 or P2? So P3 is already done at the 6th second. Yes, P2 will complete its execution next. So yeah, what happens is after 6 seconds, P3 is done with the execution, so it is handed over to P1 again. Another 2 seconds pass by, so P1 is still left with 3 seconds of execution time. So then P2 comes in, it is left with 1 second. So P1 completes its execution. So 8 seconds have gone by. So at the 9th second, P2 has completed its execution. And then can anybody tell me what will happen? So will P1 continue to execute, or after 2 seconds there will be an interrupt, and then the operating system will find no other processes, and then again P1 the control CPU time will be given to P1. So swapping in and swapping out, what will happen? Yes, There are many approaches actually depending upon the operating system. Some may allow the full time of rest of the time, that is 3 seconds of execution that is left for P1, or some may interrupt. Anyway, we will get into the details later. Okay. So yes, that was the question. So that was the answer. Let's move on to the next question. So as we know, an operating system is divided into multiple modules. An operating system may be divided into multiple modules. So they have the advantage of not getting affected system wide when module is changed. They comprise the kernel with all the modules. They provide more flexibility and functionality with each module, or all of the above. Which do you think is more correct related to multiple modules of the operating system? Which among the four? Again, there may be more than one correct also. So this is another question that I have picked from last year. So yeah, go ahead. I'll just, the recording is being properly done. So those who are new to this, so I want to say that this is a, so somebody has said 9. I do not understand 9. So anyway, those who are new to this, so this is a live session which will be recorded, and yes, I have to report it to NPTEL. So this session is being recorded. So if you want to contribute, please contribute through the chat box, and I have access to the chat box. I can see your answers, as you may know. And every Tuesday from 6 to 7, this will be the live session for the next 10 weeks also. This is the second week, so there will be 10 more weeks of this course. Anyway, let's go to the answer. So yeah, all of the above are correct for this question, and let's go to the next question. So memory management activity, this is an OS service, as you may know, operating system service. So memory management activity does not involve keeping track of which part of the memory is currently in use and by whom, deciding which processes and data to move in and out of memory, suspending and resuming processes, allocating and reallocating memory space. So which among the following four is not a part of the memory management module of operating system? Would anybody like to contribute? Okay. Anyone else? Okay. So memory management, as you may know, is also an essential part. Memory, by memory I mean main memory of the computer. Okay, so that is RAM. So managing RAM is a very essential part. RAM holds a very key storage unit for the operating. RAM is a very key storage unit for the operating system, in the sense that it is centrally located in the storage hierarchy. You may know about the storage hierarchy. We had studied about it in the previous class. So in the sense that it has enough amount of storage capacity and enough amount of speed. It maintains that balance among storage capability and speed. So it is very important that it is managed properly, that which parts of the hard disk are stored in the main memory. And we will see in the later lectures, in the later chapters, that there are chapters and algorithms dedicated to bringing certain sections of the hard disk, or the certain sections of the processes, active process, that are brought into main memory so as to utilize the main memory efficiently. So yeah, it holds a very key it is a very key activity of the operating system, memory management. So nowadays there are like huge amount of main memory available, like 16 GB or 32 GB, but in previous times it was like 512 MB of main memory that was available. So the algorithms had to be more picky and very good. It's wrong to say more picky, because the algorithms are the same algorithms are used still, but yeah, you understand it. Anyway, so let's go to the answer now. Yes, C is actually the correct answer. That is, suspending and resuming processes is not actually a part of the memory management module. So this is part of the process management. So rest of the things, that is as I said, that keeping track of which part of the main memory is currently in use and by whom. By whom I mean the processes. Okay, so certain processes require certain parts of main memory for its variables. For example, if you are executing a C code, so it needs parts of the main memory to store certain variables, to store data, to store temporary data also. If for example to store arrays, for that it requires contiguous locations of the main memory and so on. So yeah, so that is a part of the memory management module that keeps track that which part of the main memory is currently in use and by whom. And there for multiple users it becomes more complicated. So yeah, as I said, there are important algorithms dealing with which processes and data to move in and out of the main memory, so as to use the main memory more efficiently, to use the complete main memory that is available more efficiently, so that the maximum processes can be activated at the same time if needed. So yeah, and allocating and reallocating memory space. So this is also a part of the memory management modules. Allocating dynamic allocations also. In fact, in C codes, you may know that there are malloc, calloc, and realloc. So these are used for dynamic memory allocation at runtime. So memory also, yes, as I said, that memory refers to the random access memory. That is the memory that we are referring to when we say memory space. So yeah, these are also required parts of the memory management module. So yeah, but suspending and resuming processes does not relate to main memory. So as such, so it cannot decide on suspending or resuming processes. So yeah, this is not a part of that. So anyway, let's move on to the next question. So now we come to file system management. So which of the following is not a task of file system management? Can anyone identify? That is, backup files onto a stable storage media, optimizing and deciding which file data to be stored in the main memory, primitives to manipulate the files and directories, mapping files onto a secondary storage. So which of the following is not a task of the file system management? Can anybody say? Okay. Okay, I got one answer. Anyone else like to contribute? I got one answer. D. Okay. B. Okay. People are still joining and giving. I think network issues anyway. So which of the following is not a task of the file system management? So let's go to the answer now. So yeah, optimizing and deciding which file and data to be stored in memory, that is not a part of the file system management. This is part of the memory management module. Okay, this is the answer. Let's move to the next question. So this is also related to cyclic dependency. So in cyclic dependency, as you may know, so a process is holding a resource and is requesting the operating system for another resource which is being held by another process that itself is requesting for the resource that the current process is holding. Okay. So in this way it creates a cycle of dependencies with respect to the resources among processes, and this, okay, the 11th answer is option B, that is optimizing and deciding which file data to be stored in memory. So this is the answer. So anyway, you will get access to these files, as I heard from NPTEL team. So you will get access to these PPTs. So yeah, anyway, so let's resume with the cyclic dependency question. So yeah, so can you identify which of the following is an example of cyclic dependency? So I have created 4 hypothetical situations here. So P1 refers to process 1, R1 refers to resource 1. So similarly P2 R2, P3 R3, and so on. Okay. So the first situation is P1 holds resource R1 and waits for resource R2, while P2 holds resource R2 and waits for resource R3. P1 holds resource R1 and waits for resource R2. P2 holds resource R2 and waits for resource R1. Third situation is P1 holds resource R1 and waits for resource R2. P2 holds resource R2 and waits for resource R3 that is held by process P3. And the fourth situation is P1 holds resource R1 and waits for resource R2. P2 holds resource R2 and waits for resource R1 and R3. So which among the following are examples of cyclic dependency? So cyclic dependency, as I said, that a process is holding a resource and is waiting for another resource that is held by another process, which itself is requesting a resource that the current process is holding. So there is a cycle among the resources. So there is a cycle among the processes with respect to the resources that they are currently allocated with, and they want for for continuing execution. So we will see in the later parts of the course that how these are handled, but this is a very preliminary example of cyclic dependency. And can you identify which are correct examples of cyclic dependency? That is, where will be a dependency, a cyclic kind of structure with respect to the dependencies among the resources, relating to the dependencies with respect to the resources among the processes. Can you give an example? There may be more than one options that are correct. Okay, C. So I have not said anything about process P3. I have not said that P3 requires some resource. Any more answers? There may be more than one options correct. So don't worry if you don't get the idea right now. When these are all taught in detail, I'll be explaining more examples with diagrams and stuff. So I did not want to go into the details of the stuff or the complications of the stuff right now. Just seeing some small questions. So anyway, yeah, so B and D are correct. That is, P1 holds a resource R1 and waits for a resource R2. P2 holds resource R2 and waits for a resource R1. So as you can identify, there is a cycle among these two processes. P1 is holding R1 and waiting for R2, and P2 on the other hand is holding R2 and waiting for R1. So it's a clear cycle. In the first example, sorry, I skipped the first one. So in the first example, P1 is holding R1 and waits for resource R2, but P2 is holding R2 and waits for another resource, that is R3. So R3 is not held by anyone. So P2 P2 has hold of R2 and it is waiting for a resource that is already free. So P2 can complete execution, and this is not an example of cyclic dependency. P2 is not dependent on P1 or any of the related processes that are creating a cycle with P1. Okay. In the third example, P1 is holding R1 and waits for R2. The resource R2 is held by P2, and P2 is waiting for resource R3 that is held by P3. So P3 can complete its execution, and P3 is not dependent on P1, right? So the cycle breaks off. So P1 is dependent on P2, in short, right? P2 is dependent on P3, but P3 is not dependent on P1, so it breaks the cycle. It does not create a loop, it does not create a cycle. Okay, so this is not an example of cyclic dependency. Let's come to the fourth example, that is P1 holds a resource R1 and waits for a resource R2. P2 holds a resource R2 and waits for a resource R1 and R3. So again, P1 is waiting for a resource that is held by P2. So there is a dependency among P1 and P2, and again P2 is holding a resource that is currently held by P1. So there is another dependency among P2 and P1, right? So this creates a cycle. So so this creates a cycle. So this is another example of cyclic dependency. Although R3 is not being held by any process, R3 is free. So but R1 is not free and R1 is held by another process. So yeah, that creates a cyclic dependency. So these two are examples of cyclic dependencies, right? Let's move on to the next question. Okay, so fork is a pretty interesting system call. So this may not have been taught in class, but since we were studying about system calls, I wanted to introduce this. So we will be studying more detailed questions related to fork later, but since this is a very interesting topic, and I just wanted to start off with it anyway. So yeah, what fork does is it creates a new process that we can call as a child process, and that new process continues execution with the parent concurrently with the parent process from the point after it was called. So for example, here from the parent process I have called fork, so the child process will continue execution from this point onwards, right? So the parent process will also concurrently execute, but the child process will continue execution from this point onwards. So I have asked for the output. So so getting the telling what the exact output will be, that is tough. But can you tell me that how many statements will be printed? Can you give an idea, given that it is starting with 0 and it executes up till less than 2, this loop up till executes up till less than 2. Can you just give me a rough idea? So how many printf statements will be printed onto the screen? Any idea? I'll go through the explanation once. So 111, no. 111 is very high. Any other answers? You may be wrong, that's no problem. One, okay. 2, okay. 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 So this is a very interesting topic, fork. There are a lot of subtopics related to fork system call, like zombie process, orphan process, because there are we are calling it parent process and child process, so there are orphans, there are zombies related to this topic. So maybe at a later stage of the course we will be revisiting the fork topic, but yeah, I just wanted to give a brief introduction just for your interest. So I have seen this in Unix, but like Linux operating systems, but I'm not I don't think it is available in Windows. Okay, but you may study about fork system calls. It's very interesting. Anyway, let's get to the output. So the answer is 6. There will be 6 statements that will be printed. Anyway, so let me just revisit this code once. So what get PID, so what this function, this is also a system call. So what this does is it gets the process ID of this currently running process. Okay, and what fork does is fork will return so fork is a system call, right? As I said, it will create a child process and it will return the process ID of the child process that it has created, right? Okay, so we start with the main process. We come to this loop. Okay, the value of I is 0. Then we are calling fork. Okay, and then suppose we are continuing with there are 2 processes that are created. One is the main process and one is the child process, right? So in the main process, in the parent, so we'll call this we'll call the main process the parent process, right? So in the parent process, so this it comes to this statement. Now it will print that its own process ID, right? It will since we are printing the PID, and fork returns the process ID of the child that it has currently created. So it will print the child process ID and it will print the value of I, that is 0 currently, right? So So after that it will increment, so the value of I will increment. There is one child process already, right? So the child process will now come to this statement. It will execute this statement, so it will print its own process ID by get PID. So the child for the child process, fork returns the value 0. So in the parent process, the fork returns the process ID of the child. So in the child process, fork returns the value 0. So it will print process ID of its. So in the child process, it will print its process ID. It will print 0. It will print the value 0 since PID is getting the value 0, and it will print I also 0, right? So yeah. So this is for the first child process. In the next loop, again another child will be created, right? Of the parent in the next loop of the parent process, another child will be created, right? So that will also run parallelly. So the parent process will print this statement twice, right? And also it will create two child processes which will also print these statements, right? And the first child, it has the value of I, so it has left at when the value of I was 0. So it has another round of execution of I, so where it will create another child itself, right? So anyway, so this is how it started. So this is the parent process. As you can see, the process ID 12973. It has created the first child 12974, and the value of I is currently 0. Then it comes to its so the process ID is still 12973. It has created another child 12975, and the value of I has incremented to 1, and then the parent process has finished execution. So the first process ID of the first child is 12974. So this first child is has now started is now printing its printf statement. So as we can see that its PID value is 0, right? So it from the get PID we can get its own PID, so that is 12974, and understand that it is the child, it is the first child, right? And the value of I is 0 currently, as I said. So this is the second child, as we can understand from the PID again, and again this has also got the value 0, right? And the value of I, as we can see, so this is the second child. So this is printed when the value of I has reached 1, right? So this is the printf statement of that child, right? And again the first child, as I said, has one more execution to go since it started with 0. So when it returns to this loop, it will call fork again. It will get the PID value of its own child. So the first child has another child, right? So the parent, so the complete parent is now the grandparent, right? So 12973 is now not just the parent of this process, it is the grandparent of this process. This is the new process that it has created, right? And 12974 is in now I equals to 1, right? So 12976, that is the grandchild, will now go on to the print statement that it is left, and then all the processes will complete execution. So in this way there are 6 statements that will be printed. So it will be explained in detail later also. Okay. Anyway, let's move on to the last question for this session. So this is another question related to fork. So can you guess how many child processes, not printf statements or anything, you just have to guess the number of child processes that will be created in one execution of this. So this is for I equals to 0 to n, I plus plus, fork is being called. Can you guess among these 4 which is correct? Of course only one is correct for this case. Can anyone guess which is correct? So I'll try to explain in more detail at a later part of the course the work of fork system call and how it is done. Okay, I have one answer. Anyone else? Okay. Anyone else? I have 4 answers. 3 in fact. Okay, let's just go to the answer. It is 2 to the power n minus 1, that is B. Yeah, B is correct. So let me explain you how. So when the value of I is 0, only one process will be created. So now we have 2 processes, the parent process, the child process. When the value of I will be 1, so 2 processes will be created, one from the parent, one from the child, right? When the so now we have 4 processes. So now when the value of I is 2, so 4 new processes will create 4 will call fork 4 times, and 4 new processes will be created, right? So in this way there is a complete binary tree that is created. From 1 there will be 2, there will be 4, there will be 8. So in this way it will expand, right? So if you sum up all these, it will come up to 2 to the power n minus 1, right? So that's it for this session. Thank you all for joining. So hope to meet you in the next session. Okay, so yeah, I'll explain in more detail the fork system call maybe at a later stage of the course. I'll revisit this concept of fork. Okay, so I just wanted to start it. So you can have a look from a lot of online resources. Okay. Yes, actually the attendance is being recorded. Like it's not a compulsory thing that you have to join, but it's optional. Maybe, yeah, okay. Maybe this is the first time that you are joining, so it's not a compulsory thing. It is completely optional, and yeah, I'll try to solve some numericals that will help you solve the current assignments related to the course. Okay. Will there be any negative marking? I am not aware of the examination pattern or things like that. So yeah, you have to maybe ask it in the discussion forum, right? So anyway, let me just stop the recording.